You wake up, your phone is dead, not the battery. Dead. You check the router. Nothing. Outside, cars have stopped mid-intersection, traffic lights dark, the hospital 2 blocks over, backup generators struggling, satellites tumbling silent above, 6 million GPS receivers showing your tractor in the wrong field by 230 feet. This is not science fiction. This happened in Quebec in 1989. It happened to American farmers in May 2024 when they lost $500 million in a single planting season. The sun did this, and scientists just found evidence of a storm 14,300 years ago that makes everything you've heard look like a campfire. 7 events, 7 timestamps, where the sun reached out and touched our grid, our satellites, our way of life. Each one proves we live one coronal mass ejection away from going dark. Which ones nearly ended us? What happens when the next one hits? 5 transmission lines from James Bay trip offline, 9,450 megawatts gone. Load at 21,350 megawatts. The math does not work. The system collapses in under 2 minutes. Churchill Falls goes offline. Mania Otardes goes offline. Montreal Metro shuts down during morning rush. Dorval Airport closes. Stalled elevators. Dark tunnels. Breakfast in cold homes. 9 hours to restore service because the equipment itself had to reboot. The James Bay network offline in 90 seconds. This was not a direct hit. The storm measured negative 589 nanotesla on the DST index. Carrington, in 1859, possibly hit negative 1750. Quebec was a warm-up. Also comment from which city you are hearing this from. Also, this script is researched and factual using sources from the peer-reviewed journal Space Weather, published in 2019 by David Boatler of Natural Resources Canada, analyzing magnetogram data and historical records from March 1989 and from declassified Hydro-Quebec technical reports documenting the exact timeline of the Cascade failure. These are not news summaries, these are engineering postmortems. Now back to the information. The second CME moves at 1,320 kilometers per second, 31.5 hours. It catches the first one. They merge. This creates a compression wave. At 1:27 Universal Time, on March 13th, the storm sudden commencement hits. 70 nanotesla jump recorded at observatories. Then at 2:44 a.m., Quebec time, substorm collapse. The timing was surgical. External triggering amplified the geomagnetically induced currents beyond what the grid could handle. Quebec sits on the Canadian Shield, Precambrian igneous rock, electrically resistant. The currents could not flow through the ground, so they flowed through the 735 kilovolt transmission lines instead. Transformers overheated. Static compensators at Chibougamau tripped. La Vérendrye substation went offline. Harmonics started propagating, voltage oscillations, power swings. Then the James Bay lines failed and the entire grid went dark. Journal Earth, Planets in Space. They analyzed tree rings from the French Alps, radiocarbon spikes, carbon-14 isotope levels 18% higher than the 775 AD solar storm, which was previously the strongest on record. The 2025 paper, authored by Ksenia Golubenko and Ilya Usoskin, used a chemistry climate model called SOCOL:14C-X. This model reconstructs solar particle storms under glacial climate conditions. The 12,350 BC event deposited charged particles into the atmosphere at a rate 500 times more intense than the 2003 Halloween storm, which was the most powerful in the satellite era. The Halloween storm registered negative 383 nanotesla. The 12,350 BC storm would have obliterated any grid. No transformers, no satellites, no GPS. The event lasted days, maybe weeks, protons and electrons cascading through the magnetosphere, the aurora visible at the equator. If this happened today, every satellite in low Earth orbit would tumble. Every power grid at high latitude would fail within minutes. Telecommunication cables would melt. The economic cost? Estimates range from $2 trillion to $10 trillion in the first year alone. Recovery time? 5 to 10 years for full grid restoration. The 12,350 BC storm sets the new worst-case scenario. Golubenko's analysis shows that similar events likely occur every few thousand years, meaning we are overdue by statistical measures. Richard Carrington, British astronomer, Red Hill Observatory near London, September 1st, 11:18 a.m., Eastern Daylight Time. Carrington is sketching sunspots. Suddenly, 2 brilliant beads of white light appear over the sunspot group, kidney-shaped, intensifying. He runs to get a witness, returns in 60 seconds. The flare is already fading, 5 minutes total duration. But the coronal mass ejection is already hurtling toward Earth at unprecedented speed, 17.6 hours. That is the transit time. Normal CMEs take 2 to 3 days. This one hit at lightning speed. September 2nd, geomagnetic storm begins. Dusty index estimated between -800 and -1750 nanotesla. Telegraph systems worldwide fail catastrophically. Operators report electric shocks. Telegraph paper catches fire from sparks. In some locations, operators disconnect batteries and transmit messages using only the auroral current. This is not legend. This is documented in telegraph company logs from 1859. The aurora borealis, visible in Cuba, Hawaii, Colombia. Ships crossing the equator report red auroras overhead. Compasses spin uselessly. The Carrington event hit during the solar maximum of cycle 10. We have ice core data going back 500 years using nitrate deposits from energetic particles. The Carrington event sticks out as the largest spike, nearly twice the runner-up. If Carrington happened today, satellites would be the first casualty. The radiation would fry circuits, solar panels would degrade, communication systems would go offline. The International Space Station crew would have minutes to take shelter in the shielded modules. GPS would fail globally within hours. Power grids would experience geomagnetically induced currents 10 times stronger than Quebec, 1989. Transformers would melt, substations would explode, the damage would cascade. One grid failure triggers load imbalance in neighboring grids. The entire North American grid could go dark in under an hour. Europe would follow. Recovery time? Engineers estimate 18 months to replace damaged transformers, but only if we have replacements ready. Most utilities keep few spares. Production time for a large power transformer is 12 to 18 months under normal conditions. During a global crisis, 5 years minimum. 3 days, May 13th to 15th. Solar cycle 15, declining phase. Sunspot region AR 1842 crosses the central meridian. The region is magnetically complex, 151,000 kilometers by 34,000 kilometers. May 12th, flaring begins. One explosion after another. Coronal mass ejections aimed directly at Earth. May 13th, 1:08 p.m. Greenwich. Meantime, sudden geomagnetic impulse. 107 nanotesla average across multiple observatories. Only 1% of storm sudden commencements are this strong. The solar wind dynamic pressure estimated at 64.5 nanopascals. Normal quiet time pressure is 1.6 nanopascals. The magnetosphere compresses. May 15th, the second impulse arrives. This one is stronger. DST index peaks at -907 plus or minus 132 nanotesla, comparable to Carrington, possibly equal. Recent analysis by Jeffrey Love at the U.S. Geological Survey and Mike Hapgood at Rutherford Appleton Laboratory reconstructed the timeline using magnetometer data that did not go off scale. Published in the journal Space Weather in 2019, the findings upend conventional wisdom. We were taught Carrington was the strongest. Now we know May 1921 matched it. The switchboard at the Central New England Railroad station catches fire. Telegraph operator Hatch reports being driven away by flames that engulf the equipment. The building burns to the ground. Loss, $6,000, 7:04 a.m. May 15th, New York Central Railroad. The entire signal and switching system below 125th Street goes offline. Fire in the control tower at 57th Street and Park Avenue. Railroad officials formally blame the aurora. Long-distance telephone lines in New Brunswick burn out. AT&T reports voltage spikes up to 1,000 volts on some lines. At 5:30 p.m. in Chicago, 60-volt surge on the coaxial cable between Chicago and Nebraska. 30-minute shutdown of the Bell cable link between Plano, Illinois, and Cascade, Iowa. Auroras visible in Los Angeles, Atlanta, Texas. In the Pacific, red auroras from Samoa and Tonga. Ships at sea crossing the equator report brilliant displays. The May 1921 storm proved that solar storms can ignite fires through electrical induction. If this happened today, data centers would burn. Undersea fiber optic cables have power feeds that would experience massive surges. Cooling systems would fail, server farms would overheat, the internet backbone would fragment. Cloud services would go offline, financial markets would freeze, electronic banking would stop, supply chains would collapse within days. One estimate suggests 10 times the normal lifetime dosage for a moonwalker caught outside in a spacesuit. Inside the aluminum hull of the Apollo command module, radiation would have been attenuated to 10%, still enough for severe nausea and cellular damage. A bone marrow transplant might have saved them. McMath region 11976, extraordinarily magnetically complex, August 2nd through 11th. 3 powerful X-class flares in 15 hours. August 4th, 6:21 Universal Time. X-class flare launches the fastest coronal mass ejection ever recorded, 14.6 hours to Earth. As of November 2023, this record still stands. The preceding flares cleared the interplanetary medium, creating a highway for the fast CME, similar to the July 2012 solar storm mechanics. The August 4th CME traveled at an estimated 2,850 kilometers per second. Near Earth, solar wind velocity exceeded 2,000 kilometers per second, 0.7% the speed of light. Instrumentation went off-scale. A Guam magnetogram shows the shockwave traversing the magnetosphere at 3,080 kilometers per second. Sudden storm commencement time, 62 seconds. AT&T reported the effects immediately. Voltage surge on the Chicago to Nebraska coaxial cable, 30-minute shutdown on the Plano, Illinois to Cascade, Iowa link. Canadian Overseas Telecommunications Corporation reported current surges damaging system components. A 230,000-volt transformer at British Columbia Hydro and Power Authority exploded. The storm caused auroras visible from Illinois to Colorado. But the real damage was invisible. Polar stratospheric ozone depletion, 46% at 50 kilometers altitude, persisted for 53 days at 39 kilometers. Solar energetic particles reached Earth's surface, ground level enhancement event. Cosmic ray flux dropped dramatically, a 4-bush decrease. And then there were the naval mines, August 4th, 1972, Han La area near Haiphong, North Vietnam. Dozens of U.S. Navy destructor magnetic influence sea mines detonated within 30 seconds. Magnetic latitude approximately 9 degrees, not near the poles, not high latitude. The mines were designed to detect changes in the magnetic field caused by ships. The solar storm created those changes. A declassified U.S. Navy report, analyzed in a February 2025 paper in The Conversation, concluded a high degree of probability that the August solar storm caused the detonations. Admiral Bernard Clary, Commander-in-Chief of the U.S. Pacific Fleet, ordered the investigation on August 15, 1972. The minimum self-destruct time on these mines was 30 days. They detonated after 4 days. The storm was the only explanation. If the August 1972 storm happened today, military systems would fail. Detection grids would give false positives. Navigation systems would drift. Communication satellites would tumble. Every weapon system dependent on GPS would lose accuracy. Strategic early warning satellites would experience sensor anomalies. Defense networks would fragment. The window of confusion could last hours, maybe days. In a crisis scenario, that window could be catastrophic. Solar cycle 23. 3 massive sunspot groups appear on the sun's surface in late October. The largest, region 486, measured 13 times the diameter of Earth. Complex magnetic structure. 17 major solar flares in 2 weeks. October 28, X-17 class flare. Later upgraded to X-45 after analysis. The most powerful flare in recorded modern history until possibly exceeded by ancient events. The GOES satellite detectors saturated. Data recorders pegged uselessly. October 28, 10:03 Universal Time, the X-17 flare erupts. Coronal mass ejection travels at 2,125 kilometers per second, almost 5 million miles per hour. Arrival time, 19 hours. October 29, extreme G5 geomagnetic storm. Density index negative 383 nanotesla. Lasted 27 hours. Then, before it ends, region 486 flares again. October 30, X-10 class flare. The storm continues another 24 hours. November 4th, X-28 class flare. Not aimed directly at Earth, so only a moderate geomagnetic storm, but the damage from late October was extensive. 12 transformers in South Africa damaged beyond repair. South Africa is at low magnetic latitude. This should not have happened. Malmö, Sweden experiences power outage, 1 hour. Transformers melted. In the United States, over 200 power grid problems erupt coast to coast within minutes of the storm's start. Fortunately, none caused blackouts, but operators worked around the clock. NASA's TDRS, one communication satellite, recorded over 250 anomalies. High-energy particles invading sensitive electronics. The Solar and Heliospheric Observatory, SOHO, temporarily failed. The Advanced Composition Explorer, ACE, damaged. The International Space Station crew took shelter in the Zvezda service module. Hardened against radiation, airline pilots rerouted flights away from polar regions, avoiding radiation exposure. Cost estimates suggest $100,000 per rerouted flight. Auroras visible in Texas, Florida, California, southern Europe. At low Earth orbit, atmospheric drag increased. Satellites required thruster burns to maintain altitude. According to a 2021 analysis in the journal Space Weather, the majority of low Earth orbit satellites were temporarily lost. Ground teams spent days around the clock re-establishing positions and control. About 1,000 satellites were in orbit during October 2003. By the time of the May 2024 Gannon storm, over 10,000 active satellites plus 37,000 pieces of orbital debris larger than 10 centimeters. The Halloween storm with today's orbital environment would trigger a cascade of collisions. Space debris events would generate more debris. Satellites would fire thrusters simultaneously to avoid collisions. Some would run out of fuel. Others would tumble offline. Communication networks would degrade. Weather monitoring would suffer. GPS accuracy would plummet. The economic impact of satellite losses could exceed $100 billion. If you have stayed this far, subscribing helps us keep making these deep dives into documented events. These are not speculation videos. Every number, every name, every timeline comes from primary sources, peer-reviewed research, and declassified records. Comment from which city you're watching. Now back to the storms. Active region NOAA 9077, located near the center of the solar disk. Complex magnetic field with delta structure. Sunspots of opposite polarity within the same penumbra. 10:03 Universal Time, flaring begins. X 5.7 class flare peaks at 10:24 Universal Time. Later, analysis upscales this to X 8.1 after calibration corrections. The solar particle event begins at 10:41 Universal Time. S3 rating, strong. High energy protons penetrate Earth's ionosphere. Satellite imaging systems fill with noise. 10:54 Universal Time, halo coronal mass ejection detected in coronagraph data. Earth-directed, full halo, speed approximately 1,800 kilometers per second. July 15th, CME arrives. Geomagnetic storm peaks late July 15th. KP index reaches 9. Extreme G5 storm. DST index negative 301 nanotesla. Interplanetary magnetic field. BZ component reaches negative 60 nanotesla. This is the southward component that connects with Earth's magnetosphere and drives energy into the system. Substantially stronger than the negative 50 nanotesla during the May 2024 storm. However, the extreme values did not last as long, which explains why DST only reached negative 300 compared to the provisional negative 406 in May 2024. The power of the CME pushed the magnetopause, the boundary of Earth's magnetosphere, inside geostationary orbit. Satellites like GOES were exposed to turbulent solar wind for several hours. Star trackers saturated, solar panels degraded, communication systems struggled. The Advanced Composition Explorer lost contact temporarily, crucial for space weather forecasting, because ESA sits at Lagrange point 1, upstream from Earth, providing early warning. When AC goes offline, we go blind. The Bastille Day storm caused minor damage to power transformers, satellites short-circuited, HF radio communications disrupted, ground level enhancement event, particles reaching Earth's surface, fifth strongest over 5 decades of GOES observations. Greater than 10 MeV proton flux peaked at 24,000 particle flux units. Polar cap absorption event lasting more than 3 days. Radio blackouts across polar regions. Zhongshan Station in Antarctica reported PCA starting at 10:40 Universal Time July 14th, ending only at 19:40 Universal Time July 17th. If Bastille Day happened today, the damage would be worse. We have more satellites, more dependencies. GPS systems guide tractors, ships, airplanes, emergency vehicles. In May 2024, American farmers lost over $500 million when GPS went offline for days. The Bastille Day storm would do similar damage, but across more sectors. Maritime shipping would halt. Container ships navigating ports rely on centimeter-level GPS accuracy. Without it, ports close. Supply chains freeze. Aviation would ground flights at high latitudes. Radiation exposure too high. Diversions too costly. The financial markets depend on GPS for time synchronization. High-frequency trading algorithms require nanosecond precision. GPS provides that precision. Without it, markets could suspend trading to prevent cascading failures. Bastille Day today would cost the global economy an estimated $50 billion per day of disruption. May 9th, X 2.25 and X 1.12 class flares, both with full halo coronal mass ejections. May 10th, X 3.9 8 class flare. May 11th at 1:23 Universal Time, X 5.4 to X 5.7 class flare. Another asymmetrical full halo CME, at least 5 Earth-directed CMEs. They merged in transit, amplifying each other. The result was a geomagnetic superstorm. May 10th through 13th, extreme G5 storm. DST index reached negative 412 nanotesla at 3:00 Universal Time. May 11th, some readings indicated negative 518 nanotesla. API index on May 11th was 271, higher than March 1989, second highest AP index ever recorded after November 13th, 1960, which was 280. The plasmasphere, the protective layer of charged particles surrounding Earth, collapsed. Normally, the outer boundary, the plasma pause, sits around 44,000 kilometers above Earth. During the Gannon storm, it plunged to 9,600 kilometers in 9 hours, 1/5 its normal size. The Japan Aerospace Exploration Agency's RSA satellite was perfectly positioned to record this. First-time scientists captured real-time data of such dramatic plasmasphere compression. The collapse lasted days. Recovery took more than 4 days because of a negative storm in the ionosphere that cut off the supply of fresh particles. Published in the journal Earth, Planets in Space in November 2025 by Atsuki Shinbori at Nagoya University. The storm caused measurable effects globally. GPS receivers showed errors up to 230 feet during the worst 6 hours on May 10th. High-precision GPS positioning disrupted on the entire sunlit side of Earth for more than 12 to 15 minutes. Then, the auroral lights caused further GPS disruptions, as charged particles trickled through along disturbed magnetic field lines. Errors up to 30 feet persisted for the duration of auroras, which lasted days in some regions. American farmers in the U.S. Midwest lost over $500 million. 70% of planted acres rely on GPS automated guidance. Planters were inoperative. Corn planting delayed. According to Terry Griffin, professor of agricultural economics at Kansas State University, published June 2025 in a Space.com article, some aerial drone users flying during the storm experienced loss of control. Drones rely on GPS and magnetic signals. Several crashed. Starlink satellites experienced degraded service but remained operational. In Canada, BC Hydro and Hydro-Quebec prepared and monitored. No outages reported, unlike 1989 when Quebec went dark for 9 hours. In New Zealand, Transpower declared a grid emergency, some transmission lines taken out of service as precaution. Airlines rerouted flights to avoid high-latitude radiation. In the United States, NUAA reported power grid irregularities, degradation in GPS, high-frequency radio communication disruptions, but no widespread outages. FEMA and emergency management had prepared. The Wide Area Augmentation Systems, WAAS, which relies on ground stations to calculate GPS signal variations, lost localized performance with vertical guidance at roughly 2,000 airports in the continental United States and Alaska from Mate. 10th to 12th. This feature helps aircraft descend within 200 feet of runways. Pilots had to use alternative approach procedures. Over 10,000 active satellites in low Earth orbit experienced atmospheric drag changes. Satellites fired thrusters to raise orbits. 37,000 pieces of orbital debris shifted trajectories. Ground teams spent days recalculating collision avoidance. Automated systems triggered thousands of maneuvers. According to analysis in Space News published February 2025, this was the most prepared for and successfully mitigated extreme space weather storm in history. Gannon was strong but not catastrophic. We got lucky. The May 2024 storm was a test run, a warning shot. We passed, barely. Power grids held, satellites survived. GPS came back online, but we saw the cracks. GPS offline for days. Farmers losing $500 million. Satellites tumbling. Atmospheric drag forcing mass orbital maneuvers. Communication disruptions. Grid irregularities. All from a storm that measured about 1/3 the intensity of Carrington. Imagine if the CMEs had been aimed more directly. Imagine if the interplanetary magnetic field had stayed southward longer. Imagine if multiple regions on the Sun had fired simultaneously, as happened in October 2003. The damage would have been orders of magnitude worse. We know they can devastate modern infrastructure. We have documented 7 major events: 12,350 BC, 1859, 1921, 1972, 2000, 2003, 2024. The intervals between them are shortening as we add more data. The statistical models suggest we are overdue for another Carrington-class event. Some estimates put the probability at 12% per decade. That means within the next 50 years, we have better than even odds of getting hit, and we are not ready. The U.S. government passed the Pro-Zwift Act in 2020, promoting research and observations of space weather to improve the forecasting of tomorrow. NOAA's Space Weather Prediction Center monitors the sun 24/7. We have satellites at Lagrange Point 1 providing early warning. ESA is developing the Vigil mission to observe the side of the Sun from Lagrange Point 5, launching 2031. This will give us advanced knowledge before storms rotate into Earth view. But early warning is not protection. We need hardened infrastructure. Transformers designed to withstand geomagnetically induced currents. Circuit breakers with higher trip levels. Redundant systems. Backup satellites ready to launch. Grid operators practice simulations. In September 2025, ESA's Mission Control ran a Carrington-level simulation for the Sentinel-1D satellite launch campaign, testing operations without satellite navigation, under severe electronic disruption. The conclusion was sobering. Should such an event occur, there are no good solutions. The goal would be to keep the satellite safe and limit the damage as much as possible. Thomas Ormston, Deputy Spacecraft Operations Manager. The simulation involved ESA's Space Weather Office, Space Debris Office, and multiple Earth orbiting missions. It showed that when a Carrington-class storm hits, it is not a question of if, but when. Recovery is the priority. Survival is the goal. 1. The Sun is capable of storms hundreds of times stronger than anything in the satellite era. 12,350 BC proves this. 2. We got lucky in 1859 and 1921 because electrical infrastructure was minimal. Telegraph wires burned, trains stopped, but society kept functioning. 3. Quebec, 1989, showed that modern grids are vulnerable. 90 seconds from stability to blackout. 6 million people dark, 9 hours to restore. 4. August. 1972 demonstrated the threat to human spaceflight. Astronauts on the moon would have died. 5. Bastille Day. 2000 was a wake-up call. First major storm in the satellite era. Minor damage, but the warning was clear. 6. Halloween 2003 was the strongest in the satellite era. Satellites tumbled, power grids strained. Cost hundreds of millions in damage. 7. Gannon. 2024 was the most recent major event. We had preparation, we had forecasts, we had mitigation. And it still caused $500 million in agricultural losses alone. And each one will be dwarfed by the storms we know are coming. Because the sun is not done. Solar cycle 25 is approaching maximum. Predictions suggest peak activity in 2025 or 2026. We're entering the danger zone. More sunspots, more flares, more coronal mass ejections, more chances for a direct hit. The question is not if another Carrington-class storm will occur. The question is when. And will we be ready? Right now, the answer is no. We have early warning. We have some hardening. We have protocols. But we do not have a pipeline of replacement transformers. We do not have sufficient satellite redundancy. We do not have grid interconnections robust enough to isolate failures. We do not have public awareness of the risk. Most people do not know that a solar storm can black out the grid. They do not know that GPS can fail for days. They do not know that satellites can tumble offline. They do not know that recovery could take years. Quebec 1989 hit a world with power grids, millions in the dark. Gannon 2024 hit a world dependent on GPS, satellites, and just-in-time supply chains. $500 million in losses. The next Carrington hits a world where your car will not start without GPS, where hospitals depend on networked medical devices, where food distribution relies on logistics software that goes offline if the grid fails, where financial transactions freeze if time synchronization collapses, where emergency services cannot dispatch without digital systems. The damage will not be measured in millions, it will be measured in trillions. The recovery will not take hours, it will take years. Recovery could take 4 to 10 years. That report was published before the explosion of satellite dependency, before autonomous vehicles, before the Internet of Things, before cryptocurrency, before cloud infrastructure became the backbone of everything. If we recalculate today, the estimate would be higher, much higher. And yet, funding for space weather preparedness remains a fraction of what we spend on other risks. We spend billions on asteroid detection. We spend trillions on military defense. We spend almost nothing on hardening the grid against solar storms. The threat is asymmetric. A solar storm does not target one nation. It does not discriminate. High latitude regions suffer most, but the cascading effects touch everyone. If North America's grid goes down, supply chains collapse globally. If satellites tumble, communication networks fragment everywhere. If GPS fails, navigation stops worldwide. The storm is global, the damage is global, the recovery must be global. 22 years ago, the strongest in modern records. 7 months ago, the most recent wake-up call. 7 events, 7 warnings. The pattern is clear, the science is settled, the risk is real. The only question left is whether we will act before the next one hits, or whether we will learn the hard way, in the dark, with no power, no communication, no GPS, no satellites, staring up at an aurora that marks the end of the modern world as we know it. Scientists use it to calibrate models, to understand how induced currents flow through rock, to predict the next time it happens. Because it will happen. Not if, when. And next time, 90 seconds might be all we have.